Welcome to our presentation, Secondary Succession in Point Pleasant Park, post-Hurricane Juan. What have we learned? We would like to acknowledge that Dalhousie University operates in the unceded territories of the Mi'kmaq, Wolastoqey, and Passamaquoddy people, and the area now known as Point Pleasant Park is a place of cultural importance for the Mi'kmaq people.
And now that we've gone through our land acknowledgement, hi everyone, I'm Grace, and today we're here to talk to you about the changes in the Point Pleasant Park community since Hurricane Juan. Diving right in with some context, Hurricane Juan devastated Nova Scotia and the Atlantic provinces in September of 2003. As a Category 2 hurricane, the impacts on infrastructure throughout the Atlantic provinces were severe, with some estimates amounting to up to $200 million in insurable damages, and that's in accordance with a CBC article published just last year. In our study, we look specifically at the impacts of Juan on plant life, and more specifically, the plant life in Point Pleasant Park. It's estimated that Juan claimed more than 80,000 trees in the area, 75% of the forest coverage, again in accordance with the CBC article published in 2023. But with a lot of conservation work, Point Pleasant Park has since had its ecological community reestablished. However, the park is by no means the same. Parts of the forest that were still standing after the storm remained untouched, but the management plan designed by the Halifax municipality looked at adding diversity into the forest to prevent such damage from being able to happen again. The forest has since established itself as an Acadian forest, and this is all in accordance with the Halifax municipality regional website. And through our research, we sought to answer the question of how the forest community has changed using a variety of metrics, and if there are any evident changes in species dominance since 2004. We hypothesized that there would be evident changes to the forest community as a whole, the dominant species present, and changes in specific community metrics that we will look at more in depth later in the presentation. Moving on now to our methods.
So overall, our main objective is to observe the changes in total tree density, Shannon Diversity Index, density of red spruce versus red maple, and species richness to quantify secondary succession in Point Pleasant Park between the years 2004 to 2024 since Hurricane Juan and successive hurricanes. The null hypothesis is no statistically significant correlation between time versus the indicated parameters, while the alternative hypothesis is time does significantly affect the indicated parameters and reflects secondary succession. So for methods, we chose 6 20 by 20 meter sites in Point Pleasant Park that experienced the most tree canopy removal and uprooting during Hurricane Juan. Tree size data was collected annually from 2004 to 2024, excluding years affected by hurricanes or the COVID pandemic. All living trees at each site, greater or equal to 2.5 centimeters in diameter, were identified and measured for diameter in centimeters at breast height, or DBH, where breast height is defined as 4.5 feet off the ground. DBH was used to standardize the collected wood biomass data with available logging industry data. Using tree size data, these were the calculated community metrics: total density, species richness, density of red spruce and red maple, Shannon diversity, and P-Lewis evenness. And this was done using RStudio, regression analysis, and scatter plots. Regression analysis and the R-squared value was used to quantify the strength of the relationship between the year of study and the dependent variable. And scatter plots were used as the 6 Point Pleasant Park sites designated are not dependent on each other and do not affect each year's results in terms of tree size. For now, starting with results and discussions, for the key question 1, for the total density of trees studied over the years 2004 to 2024 in Point Pleasant Park, a slope of 8.72 means approximately 9 new trees are added to each 400 meters squared study site per year. The R2 value of 0.49 means approximately 49% of variation observed in total tree density is explained by the passing of years, which is the x-axis. The p-value is smaller than 0.05, meaning the null hypothesis is rejected, and there is a significant relationship between the Point Pleasant Park study site total tree density versus year. As the forest moves towards its climax community, slope is predicted to decrease because of competitive exclusion, where a smaller number of large woody species kind of starts to dominate and reduces the available canopy light, which is necessary and used by the smaller ground flora. So for the Shannon Diversity Index over the years 2004 to 2024, a slope of 0.06 means plant species richness and evenness at Point Pleasant Park study sites has been increasing yearly, meaning more species are established and the forest community is becoming more balanced in species abundance. The R-squared value of 0.34 means approximately 34% of variation in the observed Shannon diversity variation is explained by the passing of years, which is the x-axis. The p-value is smaller than 0.05, meaning the null hypothesis is rejected, and there is a significant relationship between the passing of time and the Shannon Diversity Index for plant communities in the Point Pleasant Park study sites. As the Point Pleasant Park forest moves towards its climax community, diversity and evenness is proposed to increase as dominant pioneer species will be joined by further new species and also expansion of previously sparse species. But also, Shannon Diversity Index may plateau in the future when density-dependent competition intensifies.
Alright, so here I will be analyzing the changes in densities within the two dominant species at Point Pleasant Park, which were the red spruce and the red maple. As the years have progressed, the total densities, they're an important measure on how various events will affect their population. The measuring of the densities is especially important when trying to determine if succession is present, as well as how population will look like in the future based on past trends after major events. When looking at the populations, both started out in 2004 at their lowest levels following the effects of Hurricane Juan in 2003. However, at that moment, the density measured by per 400 meters squared is clearly indicating that the red spruce was the dominant species. As the years go by, we see the density of the red maples overtakes that of the red spruce and becomes the dominant species. The reasons for this likely seems to be a case of succession. As the years went by and other hurricanes such as Ophelia, Noel, and Matthew occurred, the disturbance opened opportunity for the more hurricane wind resistant maples to become the dominant species in the area. In the future, as hurricanes continue to occur more frequently because of global warming, I believe we'll continue to see dominance by the red maples due to their higher resistance over the red spruce, barring another succession event or a large decline in the frequency of hurricanes in Nova Scotia.
So today the metric that I'm going to be bringing attention to is species richness, and there is a really specific reason for this. When Point Pleasant Park was undergoing conservation planning post-Juan, there was a focus on making sure the forest didn't regenerate into a red spruce dominated forest, and this is because red spruce can be susceptible to damage from storms and high winds, and so I wanted to show everyone the results we're seeing because of this work. Taking a look at this graph over here on the screen, this is a measure of species richness, so the number of different species in the environment, and we are seeing a continuous increasing trend here. We also did a regression analysis of the species richness from 2002 and 2024, and we did get a significant p-value of 2.2 times 10 to the negative 16 and an r-squared value of 0.61. So we are seeing quite a bit of correlation here. And so this data is really suggesting that we are seeing an improvement in species richness over time, and this is likely because the forest is still in its intermediate phase of regrowth, and there is still likely very active changes to soil formation and the presence of nutrients. And as this forest moves forward to its climax community, it's likely the species richness will continue to increase before we start to see a plateau. And this will be the case as long as the community experiences no further disturbances and is allowed to move towards its natural equilibrium.
When looking over all the data collected since Hurricane Juan, there are several things we can take away. Based on the information that is presented in the data, I predict that we are currently in the mid to late succession phase. After the large disturbance that Hurricane Juan created, there was a period of recovery which led to changes in the area in terms of species richness, diversity, as well as dominance. When looking at evidence from things such as the dominance of the red maples, it indicates in succession is in its later stages as the new communities are being established. We also saw a statistically significant increase in the species richness, which indicates that succession is at least in its intermediate shape, as the new communities develop, recovering from the disturbance caused by the hurricane. Another important factor that must be considered when looking at succession is the effects of the public on the park. After Hurricane Juan, Point Pleasant Park was carefully managed, which likely led it to having a much faster recovery than would otherwise be possible. This, along with any other plants that were introduced by humans after the storm, changed how succession occurred over the years as individual communities in the park recovered. I believe that as Point Pleasant Park continues towards its recovery, the indigenous perspective of viewing nature as a living thing over an object that is often exploited is key. Caring for the park as well as treating it with respect and not damaging it with carelessness such as littering or damaging plants is critical to its recovery in the future.
A big thank you to the Dalhousie University Intro Ecology Laboratory team, namely Allison Schmidt, for preparing the data for us. Special recognition to our fellow peers in the Ecology 2060 B05 lab in helping us collect the data, and students from past classes who also participated in data collection activities. Our teaching assistant, Max Henry Adams, for your support and guidance through the data collection and presentation process. Other notable contributors include Sabine Schroeder, Kyle Smith, Anna Tulini, and Ellie Gastos, who peer-reviewed our work and provided constructive feedback. Thank you.
So leading up to Hurricane Juan, Point Pleasant Park consisted of an evergreen forest where all trees were similar approximately in ages due to being planted at around the same time. The community lacked smaller trees to buffer wind and stabilize the forest canopy. There was shallow soil levels due to glacier retreat, and therefore tree root systems were spread wide but lacked deeper stable roots. As the forest approaches its climax community, metrics of species richness and diversity stabilize. Soil depth increases due to accumulation of decaying organic matter, and therefore deeper rooting hardwood species would dominate and outcompete shallow rooting plants. Abiotic factors such as light availability and soil composition would stabilize as the forest canopy is established and limits forest floor light levels.
When looking at the hurricanes that occurred following Juan, evidence indicates that they advance the process of succession. When looking at the overall tree density graphs, the hurricanes lower the population of all trees in general. More specifically, after their occurrence, the populations of red spruce did not do well in the following years. This is clear in 2005, 2007, and particularly in 2016, that the hurricanes transferred the dominant species from the red spruces to the red maples. While both populations suffered from the effects, the red maples kept a higher population and recovered much quicker. The effects of the hurricanes are made even more obvious when looking at the dramatic rise in spruce populations in the years with no disturbances. Without the subsequent hurricanes following Juan, it seems that the red maples may not have developed into the dominant species. The regression they caused the red spruces, however, advanced succession enough for this to occur.
An additional factor that could influence the forest recovery is the fact that while 75% of tree cover was destroyed during Juan, as previously stated earlier in the presentation, there was a remaining 25% that was preserved during the conservation efforts per the Halifax Municipality Point Pleasant Conservation Plan that was released in 2008. The city reported that the remaining 25% were mostly conifer-dominant groves, and this could potentially accelerate the recovery process of the forest, as they are an intermediate species that were already present during the initial recovery period, which is not typical for an area post-disturbance. This could also account for the difference in dominant tree abundance, which have historically and continue to be red spruce and red maple per our research. These conifer groves, which likely contained red spruce, were preserved and had the opportunity to reproduce with less competition for resources following the hurricane. And this could possibly explain the difference in abundance between the species. However, further study would be required to confirm this theory.